Hi, fifth graders. We're going to start lesson 4.2 today, going on with our ratios. This one is ratios within similar parallelograms. So we'll start by going over the work from yesterday or from 4.1, depending on when you did it. So in A1, rectangles A, B, and C are similar. D was not similar to any of the other three. And there's some possible explanation that you may have found. Scale factors, or you may have looked at the ratios if you were kind of looking ahead to what we were doing. So for rectangle A, the ratio was 12 to 20, which was equal to 0.6. So they've changed that ratio into a decimal by doing division. B was 6 to 10, which is also 0.6, and C was 9 to 15. D was 6 to 20. So if you do have trouble determining whether the ratios are equal, you could go ahead and do some division and see if their decimal equivalents are the same. In question 2b, the ratio of the long side to the short side is the same for all three similar rectangles. The rectangle that is not similar has a different ratio. In A3, it says possible answers, so that means that there could be more than one answer for this. Or you might say something similar. The scale factor from rectangle B to A is 2. The scale factor from B to C is 1.5. The scale factor from C to A is 4/3 or 1 1/3. The scale factor would tell you how many times greater each side length and perimeter are for the two similar figures as compared to the other. In A4, if figures are similar, their scale factors will be constant and their ratios will be equivalent. The scale factor gives the amount of stretching or shrinking from the original figure to the image. The ratio within the figure gives an indication of the shape of the original and the image since it compares the measures within one figure. Ratios are usually different than the scale factor. Then you had question B, where it says parallelograms F and G are similar because their angles are the same and their ratios are equal. So in the rectangles, it didn't matter to look at the angles because all rectangles are 90 degrees, but in the parallelograms, you'd have to look at the angle measures as well. B2 says parallelogram E was 10 to 8, which is 1.25. F was 7.5 to 6, which is 1.25, and G was 6 to 4.8, which is also 1.25. So here is where it might be necessary to change them into a decimal to see if they're equal. Additionally, know that in a ratio, you are allowed to have a decimal on the top or the bottom because you're not making a fraction. C1, the answer is yes, because you know all that the adjacent sides in one rectangle have an equivalent ratio. And because a rectangle will all have 90 degrees, all you need to know is the ratio is equal. And in C2, no, you could not determine that a parallelogram was similar just by ratio because you would need to check the corresponding angles. So again, the corresponding angle would be the angle that's in the same place in both shapes. So either like the top left for both of them would be the same. So in today, I think the lesson title originally said within parallelograms, but it is triangles. I'm very confused. It says triangles here. So I guess we'll find out. Since all rectangles have four 90-degree angles, you can show that rectangles are similar by comparing side lengths. Unique and Curtis each have methods that show rectangles are similar. Unique says that all scale factors between corresponding side lengths are equal for the similar rectangles. So she goes 2.5 times 1.5 would be 3 3/4. So notice they have the color blue. They're checking short side to short side, long side to long side. Both of them, if you multiply the small by the big by 1.25 or 1.1.5, 1.5, you would get the corresponding side in the other shape. Curtis says that rectangles are similar if the ratios of the corresponding adjacent sides within each shape are proportional, meaning equal. Proportional means that two ratios are equal to each other. So here he sees height to width is 9 to 4.5, and height to width in the smaller one is 3 to 1.5. And because 9 to 4.5 is equal to 3 to 1.5, they would be similar. You need to compare more than just side lengths of polygons to understand their shapes. In this problem, you will use angle measures and side length ratios to find similar triangles. So it does appear that we are doing triangles, not parallelograms today. So the difference between yesterday's lesson and today's lesson is that you will have to compare, in addition to the side lengths, the angles, and make sure you're looking at the corresponding angles. So are you looking at the correct angle that goes with the one on the shape you're comparing it with? So which triangles are similar? Explain. So when you're looking at these, make sure that you're looking at the angle that you want to compare. So here we have a 30-degree angle across from the shortest side. Okay, this one has a 42-degree angle across from the shortest side. So just looking right there, can those two triangles be similar? They cannot, because they do not have angles that are the same. Okay, so you'll need to look at more than just the side lengths. In question B, it says within each triangle, find the ratio of the shortest to the longest. Then find the ratio of the shortest side to the middle side. Okay, with each triangle. So here you'd have A, B, C, and D. B2 says, what do you notice about the ratios in part one for the similar triangles? What about the ratios for the non-similar triangles? So you should find that the ratios for the similar triangles should be equal. C says choose two similar triangles. Find the scale factor from the smaller to the larger. What information does that give you? In question D, compare the information given by the ratio of the side lengths in B to the information given by the scale factor in C. So that question is just like yesterday's question, where they were asking about the scale factor versus the ratio. And that is your classwork. For homework, you'll do questions 4 through 10, which sounds like a lot, but when you look at it, you will see that it is not a lot of work. In 4 through 7, you are looking at the missing measurements, find the missing measurements. Okay, here it says they're not drawn to scale, meaning don't look at if they look similar. Use math to figure out the missing side length. And in 8 through 10, it says A and B are similar. Again, remember you have to compare short side to short side and long side to long side. 8 is multiple choice. 9 is looking for the scale factor. Find the area. How are they related? All right. Have a great day.